with the button. It wasn't me. Yeah, I think it tell us a joke. We go count to 40. So go for it.
Okay, hey everyone, welcome. I'm going to talk about some Burp stuff. So my name's Tom Steele. I work at a company called Lift Security. We do application security assessments, code reviews, things like that. We also head up the Node.js security project. So if you are into Node or interested in messing with that, come talk to me. So when you're doing application security assessment, or if you're working in application security or penetration testing, I'm sure you know of Burp Suite. It's one of my favorite tools. It's more than just an intercepting proxy. In general, it's just awesome. It has two versions, Burp Suite Pro and Burp Suite Community. You should go buy the Pro. It's not that expensive. It's actually really cheap. Ding. Okay. So, if you're familiar with Burp, you might also be familiar with the Burp Extender API. And basically what it is it's a set of Java interfaces that lets you extend Burp beyond what it is. So you implement a Java interface, and in there you can do things, you can call functions that are exposed to Burp, and you can extend the functionality of Burp. Now, since Burp is written in Java and these interfaces are in Java, you have to write in a language that can talk to those. And for now, these languages are Ruby, which is awesome, Java, of course, and Python. And these are ordered by my favorites. But when you're writing with Ruby, you have to use JRuby, which actually is pretty good. JRuby is an implementation of Ruby in Java, so that you can actually call Burp's Java API from Ruby, but it runs in a JRuby like container, if you will. And actually it works pretty good. Most libraries that you try to call will work, but you're still kind of a little bit restricted into what you can do because you're restricted into Burp's interface, and you have to kind of expand out of that. So if you want to write something quick, you have to first implement that. You have to implement Burp's interface, and then upload it and go. And then with Python, it's a little worse because Python you have to use something called Jython, which is similar to JRuby, with the exception that I believe Jython only supports like the 2.5 syntax of Python, so you lose some features, so you don't have the full set. Also, if there's any C bindings to any of the languages you want to use, they won't run. You would need like a Jython or a JRuby equivalent. But I believe that Jython is in beta for 2.7, so it's probably not that big of a deal. And then some more obscure type things, you can actually write plugins in Scala and Clojure, because those compile to Java bytecode. So you can, and I like Scala more than Java because it's kind of just gets rid of some of the cruft that you have to do in Java. But they're still kind of complex languages and not so friendly. So me personally, I like to write a lot of Node, because that's what we use at Lyft and Anyet, the parent company. So we use Node.js for just about everything. But I also like Go, which is a newer language. It's kind of awesome. I'll have so basically, what I wanted to do is I wanted to be able to write Burp plugins in both of these languages, as well as other languages, and write them faster. So the idea that we came up with is this thing called Burp Buddy. And what Burp Buddy is actually a Burp extension. It's actually a Burp extension itself that lets you write extensions. So what it does is it takes the Burp, it runs as an extension in Burp, but then it exposes the Burp API over the network, and it does that in a few various ways. The first is it has its own WebSocket server. So it exposes this WebSocket interface to Burp, and it has a JSON HTTP API, so it runs an HTTP server as well. And then it has this thing we call proxy webhooks. So if you're familiar with webhooks and like things like GitHub and basically every other application that's coming out nowadays, they kind of have this functionality. But before I get into those details, I want to say thank you to whoever wrote Hiccup. It was this awesome library that was written in Python a few years back. It was actually written by Zynga, and it hasn't been maintained since. But this is where I kind of got this idea, because they were the first ones that I saw to take the Burp API and abstract it out, but they actually abstracted it out in only a Python interface. So you still have to write Python, which is kind of poop, but. Okay, so this is what the Burp Buddy extension looks like after you've loaded it up. You have your interface, which is just the IP that you want to listen on. You can control the HTTP port, the WebSocket port, the WebSocket allowed origin, which is YOLO asterisk by default, but I warn you about that. Then you have a request service URL and a response service URL. Those are for the webhooks, and you can disable any of those and save your settings. So at this point, once you have it loaded up, you have 2 listening services running on your machine. You have a WebSocket service that you can connect to, and you have an HTTP service you can connect to. So the first service is a WebSocket server. And WebSockets, if you're familiar with, if you're in web apps a lot, you might know about WebSockets. They basically let your browser connect via like a stateful TCP connection and do pub sub to a server. So we can build real-time web apps with these. But you can also do these type of things in Burp. So we don't have publish right now. We only have subscribe. And what you do is you subscribe to events. So you connect to this server, and as Burp is doing things, it will be sending you these stream of data constantly. And so anytime Burp does a request, it sends you a request. Anytime Burp has a response, it sends you a response. And then I also did this thing where I implemented a custom service, custom passive scan, so I can actually send you request response pairs. And then we can also send any issues. So as soon as like an issue comes, it will send it to any of these connected clients out in a stream, and then you can ingest those, and they're just they're JSON. If you're wondering why I did WebSockets over something like maybe an RPC interface or like with message pack, I basically did it because every single language has a WebSocket client. It has a WebSocket client. It's very easy to use. It's very quick to set up. You don't have to worry about anything for the most part. So this is a simple example in Node. The first 8 lines or so are just me opening this WebSocket connection, and then I'm listening for messages asynchronously. And they're just JSON. They're just JSON. So it's going to take this, parse the JSON data it gets from Burp, and then console log it if it's a type request. So you can see what kind of type of object you're getting. And this is what this is basically what a request object would look like. It has basically everything you would need to take a request from Burp and parse that out and see what it's sending and interact with those and do anything with those. So where is this useful? So give me it's like a sample use case. So what this video is it's a web app that's protected by a login form. Now, when you log in, you get presented with a authenticated route. But there's also a route in here called private, which doesn't require authentication, but it should. So it's broken. So most people call that forceful browsing, right? So basically, you're looking for routes that should be authenticated, but they're not. And to automate that, I don't think there is a way to do that in Burp, but you can write a little 12-line plugin that basically just listens for requests, strips the cookies out, and then sends the request again to the server. And if it's, a 200-level response, it was probably a vulnerability, right? So we'll just click through the video. So I'm running this little Node script in the bottom. Then I'm going to log in. Okay, so just showing you the proxy that I am logging in. So now I'm going to, do a GET request with a cookie. Oh, that did not pause. Oh, okay. Okay, note to self, don't try to pause the video. Okay, so what happened here is it then sent a request with a cookie. And then I clicked on the private link, and you can see, did I go forward? Oh, I went forward a slide or two, sorry. Okay, so at this point, you can see that the request that requires authentication gets 302'd back to the login form in the bottom here. And now I'm going to click private in my browser, and you'll see the request come in. It has the cookie, so you think, okay, that's an authenticated route again. But then I have this, this plugin running that's stripping out the cookie and submitting the request again, and it's getting a 200-level response, meaning that it doesn't require a cookie. You can still get to it. And so, you can write these little plugins that just do simple things like that. Okay, another thing you can do is say you wanted to ingest all the issues. Like, so as you're doing your Burp, like active scan or passive scan, you wanted to ingest the issues in a WebSocket, and maybe you wanted to slide them into a database. So this video is just me doing that, and I'm just inserting them into MongoDB. So log into Mongo, and then I'll start this this service in the bottom. So this is just listening for issues. When it sees an issue, it just inserts it into Mongo. And we'll go to my vulnerable site here. So you can see that issues pop up in Burp like they do, and they're automatically getting inserted in the database. So, this might not be immediately practical, but you can see how you could extend this beyond. You could build something that inserts in the database and maybe presents you into a web app, or maybe you share with your coworkers or something like that. Just little small pieces that do complex actions. And so this is just me querying Mongo, showing like, okay, it got inserted. So in addition to the WebSocket API, we also have a JSON HTTP API, like I said. It has 21 endpoints, so pretty much takes any function that's in Burp Extender and exposes it to you via JSON interface. So you can do things like add and remove URLs to scope, see your scope, do passive and active scans. You can affect the cookie jar, so you could add cookies for the Burp to use. You can get the sitemap, affect the sitemap, things like that. And one of the cooler things that I end up using quite a bit is posting to a tool. So you can post a request to like Repeater via just HTTP. Okay, so how does that? Just a little practical example. You can actually like write bash commands that interact with Burp now, because you can just do curl. So this first command is just me adding this URL to the scope via curl. And then I can tell Burp to spider that host via curl as well. And so what you can do is now you can start extending your functionality even more, because like for our forceful browsing example, we were just console logging saying, hey, in your little window, like, hey, I think there's a thing. But what if we wanted to turn that into an issue and send it to Burp? Well, with this little bit of code here, we can actually do that. So what this does is it takes the object you've got in the request, and it actually turns it into an issue, and then does a HTTP post to Burp's API via this URL here, and puts the issue in Burp. And so that's this video here. So doing the same thing, except I'm going to, post an issue via HTTP. So click private, which is the problem, that the page that has issue. And it goes over HTTP. Give a little helpful message. And now you see that you have this forceful browsing vulnerability in Burp. So you can write these little plugins that also, write plugins that check for issues that you care about, and you can also write plugins really, really fast that are customized for the site you're testing. Because that's a lot of the problem, is that when you're testing sites with generic plugins, you have to modify them because they interact differently. What if it was not a cookie and it was like an authentication header? You'd have to adapt that really, really fast. So, like I said, we can also do the send to tool. So what this does is just a little bit of modified thing, but instead of sending it directly to a scan issue, instead of saying this is an issue directly, let's send it to a repeater so that we can manually validate. So we click private, there's an issue, and then boom, it ends up in Repeater. So now, as you're testing, you can actually go in Repeater and manually validate this by stripping out the cookie yourself, making sure the request is correct. And, boom. So you can kind of script these in like any way that you feel, you want to, and really, really fast. Okay, so I said that there would be Node and Go. So here's a Go example. What this does is it goes and does an HTTP request, says, hey, give me the entire sitemap. Then it parses that into JSON. It parses into an object from JSON. Then it loops over each site, and it syncs it to another person's Burp instance. So I was thinking this might be useful, is if I'm working on something and you're working on something, and our two sitemaps are out of sync, and we have different notes, well, we could sync up our sitemaps. Obviously with a little bit more logic than this, because we want to do like a merge somehow. Or if I was working certain hours and you wanted to go work on my assessment, I could say, oh, okay, well, let me give you my sitemap so you don't have to go spider, or something like that. Just cut down, something simple like that. So here's a demo of that. So here I have a spider, and I have this running in a Burp VM on Linux. So you see there was no sitemap there. So I'll add a comment beep boop, and then I'll run my sync. and I can put it in another Burp instance over the network. There it is. Okay, so proxy webhooks. This is the third and final layer that we have. Whenever a request is run through Burp's proxy, it will first send the request via HTTP to a URL that you specify. So you run your own HTTP server. It gets posted with a similar object to the WebSocket. You can then interact with that object and change headers or change the request. Do whatever you want. Send that back to Burp in the reply. Burp Buddy will then mesh those together and modify your requests, and then present it to you in the proxy, as well as any response the proxy gets will send to you before. So you can modify the response before it hits your browser. Now Burp can actually do this and does it pretty well. So this actually only comes into play when you want to build like big tools. For instance, another member of my team is actually building. He liked how Burp did proxying, but he wanted a different interface. So he's actually building something that affects this, and it presents him like a web browser, and he can interact with it there. So just a real simple example is I have a web server running here with a route that is a post request to /request, and I just changed the user agent to look like an iPhone. Now Burp can do that, but I just want to show a simple example. So you can see it went to the HTTP server, got its reply, and now it looks like an iPhone. Okay, so let's do something. Those are cool and useful, but let's do something awesome, I guess. So has anyone ever used Slack, or do they use Slack? No? Anyone use Slack? Okay, so anyone use like HipChat or something familiar with that? Basically, it's just like a chat client that your team can use to communicate with each other. And it has like IRC, and but you can do integrations with GitHub and everything like that. And you can also add commands. And so you can add actually your own webhooks. And so what I did was, I programmed Slack so that when I gave it a command /burpscan URL, it would HTTP post to a server I control that URL. So this is my Node.js HTTP server that I have running on the internet somewhere. And my Node.js server takes that URL and then starts interacting with Burp Buddy that's running on the internet somewhere as well. So I can now tell in Slack, I can say /burpscan URL. It'll go to my HTTP server, and I can start doing an active scan on the URL. And this is tying all of the pieces together, kind of. So here's a video. And if you can't see it, let me know, because I'll just tell you. So first thing it's doing is in the Slack command, I'm just doing burp scan, and I'm giving it a URL of a website. And then, it's hitting my HTTP server, and then it's showing up these issues here. So if you want to do something like this, what you'd probably want to do is you'd probably want to run burp headless and then have it logged to a database, and then you interact with it with Slack as well. You could even have it post back, whatever. Just, something that you could do. Okay, let's do something cooler. What if you had a bunch of burp nodes running on the internet? Like, I did 4 for this demo because I got tired of spinning them up, but I didn't really feel like writing Ansible scripts to automate it. But like, you could spin up Burp on a server on the internet, maybe 50 of them or so, turn them into headless, have Burp Buddy listening, and you could start feeding them things to do, like bots, right? And you could do things like, do an active scan on the entire internet or something, and then log them all back to this head node. So I kind of did something like that. So, okay, so I have this command line tool that is actually, I put on GitHub so you can actually use it. It's called Burp Farm. What you do is you give it a list of URLs, you give it a list of IPs that are your bots, and you give it an IP to post back the response for any issues it gets. And so it starts up a WebSocket listener for each one, and it's listening for the issues to come back in, and it's also listening for things from the spider and the proxy, and it round robins distributes them to each Burp node. And then each of these 4 windows behind it is Burp running in headless mode with the plugin, so it's listening on an HTTP interface. And then, so what I'm telling it to do is, okay, distribute the workload, then get all the issues back and put them in a local Burp instance running on my machine. So these are publicly listing on the internet. So yeah, a bunch of stuff's going on. It's doing a bunch of stuff, and it's basically making this huge log file that's distributing the workload evenly, and then all the issues pop up on my local machine. And it goes for a while because I'm scanning like about 15 to 20 sites here. So, but you can actively see that Burp's getting errors from some of the URLs because they don't exist or they don't resolve correctly. So yeah, it's sending out to each node saying, hey, one of you nodes spider this host. And then as the spider is returning each request it gets, so as it's like getting slash and then it's getting /1 or whatever, the head node is ingesting all those and then saying, okay, you go out and you active scan it. And so it's round robin style distributed. Is that cool? I don't know. Okay, so what's next for the project? Because it's pretty much done. I mean, unless Burp changes something, there's nothing much I can do. But the code could be cleaner. The code itself could be cleaner. And also, because of how I wrote the code, you get duplicate fields in some of the objects. They're not as clean as they could be. So you get some fields that don't apply in your JSON, which doesn't affect you at all. It's just kind of like a thing I don't like. So I'd like to move it to Scala because it can run. It's a little bit cleaner of a language. It's easier for me to write. And I think it's a little bit easier for people to kind of build and run with. So we're going to do that. I'd also want to do CLI configuration because when you run Burp in headless mode, there's no way to configure the plugin unless you have a CLI interface for it. So it needs to be